Alright, how's everybody doing today? Today we're going to be tuning in a little bit to some Johann Sebastian Bach, this guy right here. Great brain music, kills the boredom a little bit. What we're going to start with is this vocab stuff, and we have probability. And the first thing we're going to talk about, when we talk about probability, and you guys kind of know this, like what's the chances that this or that's going to happen? And generally, when we speak about probability, it's anywhere from 0 to 1. We use it as we use it in a percentage. So when I say you have a 0.37 chance, that means you have a 37% chance of something happening. Theoretical probability is what should happen. Okay? So when we say, what's your theoretic probability? If I were to flip a coin 100 times, how many times would heads come up? We would say the theoretic probability is 50. Does that mean that's absolutely what's going to happen? No, not necessarily, but that's what should happen. That's the theoretical. The opposite of that is experimental probability, or maybe not the opposite, but the other side of that is this is what actually did happen. Should happen and did happen. Okay? Odds. We see odds a lot in things like boxing. What are the odds? And it's when we talk about odds, we talk about the event to event. You know, your Tiger Woods' odds of winning are, 1 to 10. Okay, that means the chances of him winning is 1, and the chances of everybody else winning is 10. In probability, we might say that's 1 out of 11. But in odds, we say 1 to 10. So those are you'll see how those things are different. And when we see the word odds, we got to think a little differently. Then geometric probability is anytime you're calculating the ratio of two lengths, areas, or volumes. What I like to always think about when I think about geometric probability is a dartboard. And what are the chances I'm going to hit the dartboard and not hit the board that's behind the dartboard? Okay, what are the chances I hit that circle and not everything else around the circle? So, all of this stuff out here, what's the chances of that as opposed to hitting the actual circle, or even what are the chances that I hit this bullseye right here? And you'll see those questions come up from time to time. All right, so let's say goodbye to Mr. Bach there. The theoretic probability of an event, when all outcomes are equally likely, the theoretic probability that an event A will occur is the number of outcomes that are A, right? And then the total things that could happen. So just total things that can happen. That's probability. Remember, that's going to be opposed to odds. And so when we look at, what's the chances that event A here is going to happen? Well, there's 3 things in event A, and there's 7 things total. So you have a 3 out of 7 chance. Theoretic probability. Well, that if I drew 7 things out of there, would that necessarily happen? If I put them back each time? I don't know. All right, let's take a look at this page here. I have a few props for later. Use a standard deck of 52. You have a checkpoint here. You guys are going to, pause for just a minute and do checkpoint 1 and 2. All right, welcome back. Use a standard deck of 52 cards. Find the probability of drawing a red queen. Well, I know that there is the queen of diamonds, and I know that there's the queen of hearts. And those of you who don't play cards very much maybe don't know that. So there's 2 queens out of 52. When we talk about probability, we have a 2 out of 52 chance of drawing a red queen. In example 2, find the probability that 4 of 7 male players on a baseball team bat first. And in this situation, you would have 4 out of 7. What's the chances that one of these guys is going to bat first? Simply just 4 out of 7. I hope you noticed. I hope some of you said, "Oh man, what's going on?" There was a page missing in all of our notebooks, including mine, for example 2. But We'll get through that. No big deal. Don't worry about that. Let's take a look at odds in favor and odds against, and that's why I brought my little bags of marbles here. When all outcomes are equally likely, the odds in favor of an event A and the odds against an event A are, okay, so number of outcomes of A is over top of not A. Okay, everything not A. All right, odds against would be not A divided by A. So when I look at marbles right here, a marble is drawn from a bag, contains 6 red marbles. So I'm going to fill my bag up here with 1, 2, 3, 4, 5, 6 red marbles, and it has 12 yellow marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 yellow marbles, and it has 9 black marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9 black marbles. So I'm putting my hand into that bag and I'm going to draw. What's the odds in favor of drawing a red marble? Well, it would be the number of reds. We said that was 6. Divided by anything not red. So not red would be the yellow and the black. So that would be 21. 6 to 21. Now, if we were talking about probability, my probability would be 6 out of 27. But odds, that's different. So 6 out of 21, and 3 goes into there 2 and 7 times. So the ratio would be a 2 to 7 ratio of reds to non-reds. What's the odds against getting a black? Well, the non-blacks, well, the number of blacks is on the bottom. The non-blacks would be the reds and the yellows. That would be 18. 18 over 9, which reduces to 2 over 1, or a 2 to 1 ratio of not blacks to blacks. I hope that makes sense. Now, brace yourself. The next page, this is from page 222. I have no idea why it's here. And 222, I have no idea. We're going to skip right over that. So just keep turning the... And our last page makes for a nice quick lesson when they forget a page of notes, and we don't really need them anyways. The experimental probability of an event. This is, I actually did an experiment, and what happened. When the experiment is performed that consists of a certain number of trials, the experimental probability of event A is given by the number of trials where A occurs, and then the total number of trials. So again, we're talking about the word probability again, not odds. So we kind of went from probability to odds back to probability, and you'll have to do that on the test as well. So exam grades, I love this little thing over here. No common sense, but a wonderful test taker. And we kind of always see the opposite of that. You know, the kid who not always a great test taker. So kind of funny. The total number of students who took the test. So if you look at all the students who took the test, we have 7 plus 12 is 19 plus 8 is 27. 31 people total took the test. All right, not like our class. Exam grades of students in the history class are shown by the bar graph. Find the probability that a randomly chosen student in the history class received a C. All right, well, there was 8 kids out of 31 who got a C, so that's my probability. All right. Of those surveyed, look at what I missed. Or better. Got to do a better job reading, right? So what I want is people who received a C or better. So that would be 8 plus 12 plus 7. 27 out of 31 received a C or better. Now let's make sure those are important words, right? Or better. So then the probability of getting at least a C would be 27 out of 31. So you have a 0.87 chance or 87% chance. All right, you go ahead and do checkpoint number 3 down there. Okay, hopefully you pause that. Marble is drawn from a bag containing 6 blue, 6 yellow, 9 white, and 11 green. Find the odds in favor. Odds in favor of drawing yellow marble. How many yellows are there? 6. How many non-yellows? 20, 30. Non-yellows would be 26. Do not include the yellows in the bottom, only on the top. Using example 4, find the experimental probability that somebody scores a C or lower. Well, let's remember there were 8 C's and 1 D and 3 F's. So 12 people, C or lower, total 31 people. And because this was probability, not odds, it's that number over the total. All right, thank you very much, folks. That was 10.3.